Good morning, sir. My name is T. Rajkumar, 23 MI 1163, going to talk about DNS over HTTPS protocol and its privacy, securing your internet queries in the age of surveillance. Understanding DNS in the Internet's phone book. DNS is the fundamental service that translates human readable domain names like www.example.com into numerical IP. So, like human readable text is converted into computer readable text, address the computers actually. The clear text problem. Traditional DNS queries travel unencrypted over UDP port 53, exposing your entire browsing history. Like it tells about the traditional unencrypted UDP port 53. So, like guys, IPS, governments, hackers, and public Wi-Fi and other intermediaries are the net trafficking persons. Complex infrastructure. DNS involves multiple servers working in concert. Your recursive resolver queries root servers which direct to TLD servers. Provided resolvers that see every single query unencrypted. So, an exploration of a critical technology and reshaping a internet security and user autonomy. So we can what we actually say that the shift to a DNS over HTTPS is not just a technical upgrade, it's a significantly change in the architecture of the internet policy. Now, the privacy problem with traditional DNS. When your DNS query travels unencrypted, they actually become a window into your entire online life. What websites you visit, what research for, what services you use. The metadata reveals intimate details about your interest, health concerns, financial situations, and benefits. Eavesdroppings and tampering and mass surveillance. Attackers intercept unencrypted DNS queries, redirecting your malicious sites through DNS spoofing and man-in-the-middle attacks. Mass surveillance. The NASA's microwave program exploited DNS monitoring for mass surveillance. RFC 7258 classifies monitoring an attack on the under DNS. So, what is DNS and why it's important for privacy? We can like internet phone domain name system translates human readable text where it is a foundational service for navigating the internet. Like that, here the problem comes with eavesdropping and tampering. The man in the middle attack. One of the most interesting part is a person can view the data and modify the data, but here he used to view the data and he won't modify anything. He will eavesdrop for many times and he will know what are the occurrings and going upon the situation. What is DNS or HTTPS? DNS or HTTP is a revolutionary privacy technology. Basically, it is developed as a privacy technology, and the core benefits are complete query encryption, resistant to censorship, protection from ISP monitoring, and major supporters are like Firefox, Chrome, Safari, DNS providers like Cloudflare, Google Public DNS, and Quad9 Open DNS. How does device work? A step-by-step journey. Understanding the mechanics of DOS reveals how it fundamentally changes the relationship with DNS infrastructure, shifting from complete transparency to cryptographic protection. Like DNS will query encryption. Devices stub resolver packages as a DNS query and sends it over an encrypted HTTPS connected to a DOS server resolver, preventing an intermediary from viewing your request. Critical privacy junction we can tell like browsing history and online habits, sensitive and political or health related information, and user location and activity patterns. Like resolution DNS resolution decrypts your query, which decrypts our query, performs the actual DNS lookup to the traditional DNS infrastructure and retrieves the IP address you requested. So it tells about the resolution part. Seamless operation is nothing but exists with the traditional DNS requires exhibit configuration and the internet ecosystem. Real-world privacy gains and important limitations. While DNS represent significant privacy advancement, it is not a complete solution. Understanding both its strength and limitations helping you make informed decisions about your online privacy. Protection achieved and remaining vulnerabilities are two important limitations. So we can say about DOS protects DNS queries from local networks like Wi-Fi and local Wi-Fi supports a wide area of Wi-Fi connected. It is used to help the users to keep protected their devices and not exploiting into malicious activities. Resistant challenges and criticism of DOHs. Despite its benefits, DOHs face legitimate criticism for network administration, enterprises, and privacy advocates who raise important concerns about implementation, centralism, and united consequences. There are four types majorly architectural concerns, centralization risk, enterprises conflicts, and operational complexity. So, like architectural concerns criticize, argue DOS breaks traditional DNS layering principles, complicating network management, parental controls, and previously easily and monitorable. Centralization risk is nothing but millions of users are affected simultaneously, and enterprises conflicts deals with impacting security monitoring and operational conflicts. Complexity requires network troubleshooting requires new skills and tools. DOHs in practice and tools like browser implementation, provider and tool options, Firefox enable DOH by default across many regions since 2019, like in America and Russia, Japan, Europe, and protecting users without requiring action. Chrome and other browsers often manual DOH configuration security and provided tool option Cloudflare and Google Public DNS, Quad9, Stubby, like future directions beyond DNS privacy, DNS privacy, DNS privacy landscape to evolve rapidly. New technologies and approaches promises to address current limitations, build even stronger privacy protection in internet infrastructure. Oblivious DOH and DNS over quick HTTPS and regulatory framework DNSC integrations like GDRP and emerging privacy regulations directly influence DOH department by data handling and practice by providers globally. DNSC integration, like it combines the DNSC with encrypted DNS, prevents spoofing attacks and ensures complete chain of trust from query to authoritative answers. So it ensures trust and DNS over QoIC and HTTP3, faster and more efficient encrypted DNS transport protocol, where HTTP is used here. This is what I mean, DNS over QoIC and HTTP3. Conclusion, protecting your privacy with DOH, like enabling DOH now, configure DOH in your browser with device settings. This single action significantly enhances your privacy with minimal effort. Choose trusted providers, research DOH privacy policies and privacy Cloudflare, GeoConnect. Stay informed about the technologies upgrading like monitoring developments in devices. So like traditional DNS leak free protocol and its vulnerabilities like legacy DNS uses a port S53 and it's transmitted data in a plain and unencrypted text. Like this creates a several major security and privacy risks. Like we can see the three risk, eavesdropping risk and censorship and filtering DNS spoofing attacks. Like another we can say is how it works to encrypted your DNS queries. DNS over HTTPS may DNS over HTTPS changes the game by running the DNS protocol over the familiar encrypted HTTPS protocol. The HTTPS tunnel, we can also say it as a tunneling. Uh, DOH encrypts DNS requests using TLS and SSL. The same encryption used for secure websites also. Many of the websites using the same encryption techniques and So likewise, this also used, but it is one more stronger than everyone, like standard and secure web traffic. So mainly for the web traffic, it is very excellent and good. Observating traffic, like it can go upwards and the resistance challenges. So somewhat I can explain here is enhanced confidentiality, protecting passive observations of browsing history by network providers, IPS, and local adversaries. Integrity assurance, like protecting DNS traffic from modification and interception, ensuring users to reach the correct intended designation. Increase autonomy, like giving users the ability to choose their DNS resolver, moving away from one mandate ISP to resolvers. So we discussed overall everything. And finally, let us conclude the benefits of the word security and anomaly and circumvention. Like here, I need to tell about three things: preventing from local spoofing. Anyone monitoring the local Wi-Fi, like a coffee shop at in like what we can say in airport or some mall centers, like can no longer read DNS queries. This is the main important thing, protecting public network usages. And next, second thing, what I need to explain is bypassing DNS filtering. In regions with strict internet congestion, DOS can allow users to bypass domain blocking and implemented as DNS level. Third one is like phishing attacks. It mitigates the phishing attacks by utilizing cryptographically verified DNS responses. So the network security cryptography plays a vital role here only, like in the phishing attacks. By utilizing the cryptographically verified DNS response, DOS reduces the effectiveness of DNS hijacking and cache poisoning attacks. I think many attacks are there, but this one is most like extreme attack where DNS can stop this by getting a verified response from the users. So overall, I conclude that. Thank you, sir.